the rationale for taking a fresh look at nuclear energy mostly today comes from the desire to decarbonize the economy. There are other benefits that nuclear provides, for example, energy independence and energy reliability. But mostly now we are interested in because it's a zero carbon energy source. So if you look at the overall energy supply worldwide, about 80% currently comes from fossil fuels, and of course associated with that goes the emission of carbon dioxide into the atmosphere, and about 20% comes from non-carbon sources such as renewables, hydroelectric, nuclear, and so on. Nuclear is about 5%. If you look at solar and wind, which are very popular these days, are less than 1% worldwide. So when we think about decarbonizing the economy, these numbers have to be kept in mind. What we're really saying is that those currently small contributors, such as nuclear, solar, and wind, have to grow by more than an order of magnitude, more than a factor of 10, to really reduce the consumption of fossil fuels. Okay, so how do we do that? Well, it's an issue of scalability, which has two dimensions. It has a temporal dimension. How fast can we get new zero carbon capacity online? And when I say online, I mean both the power sector, electricity, but I also mean transportation, because a lot of fossil fuel is used, of course, in transportation. I mean manufacturing, I mean heating, the full energy picture. So the first dimension is temporal. How fast can we put that new capacity online? The second is spatial dimension, is how much land or how many resources are we going to need to bring that new energy capacity online. And in both cases, nuclear is tremendously appealing. If you look at the current fleet of nuclear power plants in the United States, it's about 100 reactors, provides 20% of our electricity needs in the United States. Those 100 reactors were built in a period of about 20 years, and that accounted for delays and cost overruns. So with all the difficulties that were experienced, it took only 20 years to bring up about 100 nuclear power plants. Now, what that means is that it's a proven technology in terms of ramping up zero carbon power capacity in a brief period of time. The other dimension, as I mentioned, is spatial. How much land is required? So if you look at nuclear versus, for example, wind or solar, which would be not alternatives, but would be complementary technologies, it's a much more compact. It has a much higher power density. Okay, so out of a square mile, for example, you could get, with a nuclear power plant, you could get over 5,000 megawatt, which is enough to power a city 5 times the size of Boston. And in order to get an equivalent capacity with wind or solar, you would need more than 10 times the land. And of course, with the intermittency associated with solar and wind, you wouldn't get that energy all the time. So in both cases, you have something that is very attractive. The Electric Power Research Institute several years ago conducted a study that shows that if you want to essentially convert the full fleet of cars and light trucks in the United States to electric vehicles or plug-in hybrids, it would require between 150 and 200 gigawatts of power. Now, the current fleet of reactors in the US provides 100 gigawatts. Okay, so you're looking at doubling, possibly tripling the capacity of nuclear power in the United States. It's a big number, and it would be a big investment, but it's not a crazily big number and not a crazily big investment. Like I said, the 100 gigawatt that we currently have of nuclear came online in a period of 20 years. So if we're serious about, for example, reducing the use of fossil fuels in the transportation sector, nuclear can help. In terms of the big picture, the way I look at why should we invest in nuclear is a way to reduce the risk of failing at meeting the carbon emission reduction targets. Okay, Could you do all of this with solar and wind? The answer is maybe. There are some people that think that you could do it. But do you want to chase it? Do you want to take the risk of, embarking in this big investment 20 years from now, say, I failed? Unfortunately, given the current rate of climate or global warming and climate change and all of that, I think we need to have in the mix of energy sources also one that is more proven than solar and wind. And that's how I look at it. It's a way to mitigate, to reduce the risk of failure at meeting the targets for carbon emission reductions.